मिल गया था।
Yes. Yes, Jyoti, do you want to say something? Do you have anything? Okay, fine. So I assume that the slides are visible. If not, please let me know. So today we will start. Uh, I kept on telling this in previous lectures. The trade-off, if at all, between efficiency and equity, right? So let's straight away look into the set of questions that we will try to address. The first thing, if you remember, that if you start from any particular endowment, go through a competitive market mechanism, one parity optimal allocation will be achieved. Right? That's the first one. Now, second thing that you must remember, just think in a very basic terms of that two individuals and their preferences, pure exchange economy that we talk about. Then, depending on different endowments, we'll have different Pareto optimal allocations, and we have the Pareto set. Different points of the Pareto set. Okay? And a movement from one point in the Pareto set to another makes one individual better off, the other one worse off. So this much we know. The question that arises then is how to choose between two Pareto optimal allocations. The answer to that question lies in the understanding that one should choose a particular government or a particular planner should choose that particular allocation which maximizes social welfare. In this case, we have two individuals creating the society, right? Now, then we should ask, okay, I know I have one set of indifference curves or preferences. You have another set of preferences. Then how to maximize our joint utility? Then we should have something like a social welfare function. So the question is, then what is this social welfare function? And even if we define some welfare function, take for example, I take my utility, I take your utility, I just simply add them up, if that is possible. Then I get some joint utility. The question then we should ask, will that be an useful mechanism? Now, once we have defined a social welfare function, then we need to analyze the trade-off between efficiency and inequality. Right. Now, these part are core questions. We have two ancillary questions. How to measure inequality? Per se, not only inequality, how to measure poverty. And finally, if you remember, in the last lecture on market failure, we talked about briefly. We gave a hint of the normative and positive analysis, right? So now theoretically, I have a social welfare function. Somehow I am trying to maximize it and trying to analyze the trade-off between efficiency and equality on light of that particular functional form. And somehow I'm choosing the a particular Pareto optimal allocation, which is maximizing this social welfare function. This is till now in the domain of theoretical knowledge, or what we call the normative analysis. What should be done? The question is how to implement it in practicality. So from normative to positive. So these are the set of things we need to learn in this particular module. So our first module is over. Now we are into the second module. So just a very brief recap. What do we know so far? Before understanding or trying to answer these questions that we have in front of us, we must recap what we already know. First thing we know, the concept of Pareto optimality. So any point on the Pareto set is a Pareto optimal point. And by definition, Pareto optimality means no one can be made better off without making any other person worse off. First. Second thing we know is the first welfare theory. That is, if markets are competitive, the end allocation will be efficient. Third thing that we know is if I leave it to the market, I know the outcome will be efficient. But that final allocation, the distribution, the resulting income distribution, is it desirable? Might not be. So we have the fourth thing that we know. We can choose a desirable allocation through some initial redistribution in the endowments, which is the second effect. So these things we already know. So what we need to do? We need to find out a mechanism where we can balance this efficiency and equity. I'm not saying that there is necessarily a trade-off between efficiency and inequality or equality or equity. Why? Because suppose I'm moving from one Pareto efficient allocation to another Pareto optimal allocation. I'm not losing out on efficiency. Any point of OSS of the Pareto set is an inefficient point. So not necessarily I need to sacrifice efficiency. But we need to build a framework where we can do this balancing. So we start with a very simple sort of example. Two people, Robinson Crusoe and Friday, left in an island, and there was a tree that gives 12 oranges for the day. So that's the sole source of utility. One good, two people. And somehow that efficient exchange process leads to a particular endowment where Robinson is left with 10 oranges, Friday with 2. Now, that is not an equitable distribution. There is some intangible thing in that island called the government which thinks that this is not equitable. So it tries to apply the second welfare theorem. Let's take 4 oranges from Robinson, give it to Friday. So you start tampering or tweaking the initial endowment. If you take 10 oranges, 4 oranges from Robinson, give it to Friday, 6 absolutely equitable. But this transfer mechanism is not costless. You need to employ one person will go collect 4 oranges from Robinson and give it to Friday. And you have to pay 1 orange to that person. So cost of running the government, cost of implementing. So what we can say that during this redistribution process, 1 orange is lost. End result, after tweaking the initial endowment, Robinson has 6, now Friday has 5. 1 is lost in the process. This looks more equitable than 10 and 2, but inefficient. So now the clue of the debate, now why this debate is there. The moment I look, just think, once you start from one Pareto optimal allocation and move to another, there is no loss of efficiency. Both are Pareto. But if this redistribution process incurs some cost, then inefficiency creeps in. So that's the source of inefficiency while trying to achieve more equitable income distribution. So this particular example might look quite ad hoc, unreal, but that is exactly what we see.
Sir?
Yes.
Sir, in this case, we have only one product for two individuals, right?
Right.
So in the other problems, we have two products and two individuals.
Right.
So when we redistribute, if one loses some, he gets some of the other.
Correct.
If one, so that is why this is efficient, and in this case, there is only one product. If one is losing something, he is gaining nothing.
No.
Like,
No. Okay. So I wanted to make the example more simple than the examples that we have done, the particular problems that we have solved. On the particular problem, which is exactly analogous. Look, remember the problem that I gave you in yesterday's exam is very, very similar to the problem that we discussed in the last lecture. Right? And there we had two goods. We will remain in the domain of the goods. But just to give even a simpler example of redistribution, remember, someone asked a question. I do not remember exactly who asked that question. That the moment we redistribute, how do we redistribute? I say that example that I gave in the class, that mathematical example. T1 and T2, one was minus half, one was plus half. So I'm taking half value of the endowment at present prices, at equilibrium prices, and redistributing that half value to the other person, right? We still remain in that domain. What I'm saying that while I'm collecting half and giving half to another, this process, running the government, running the redistribution mechanism itself incurs a cost, which takes away partially some of your resources. So I could have taken, if you remember, I draw that graph, right? From one endowment point to the new endowment point. I can take one vertically up, so I'm just taking away good two from individual one, or I could have moved horizontally, which means I have taken only good one and given it to individual two, or anything in between, say a 45-degree line, where I'm taking 1/4 value of good one and 1/4 value of good two from individual one and giving it to individual two, right? I could have done it in that process or any other uh, combination in between. Now suppose I have started with a position where there are two goods of it, oranges and apples. Now you can think of one orange tree, one apple tree, 12 to both oranges and apples. The initial endowment of Robinson and Friday are 10 oranges, 2 oranges, while 6 apples and 6 apples. So suppose I remove that 6 apples because that's already equitably distributed. Now I can take away 4 oranges here and give it to Friday, which means both gets 6 each of both oranges and apples. So I'm just ignoring the apple part because already suppose there is an equitable distribution in that part. Because look, at the end of the day, what we try to do, I think if someone thinks closely, the link that we're trying to establish is basically everyone starts with some endowment, some wealth, and will create a two goods where good one is nothing but a bunch of private goods and good two is nothing but a bunch of public goods. So basically government takes away when you purchase uh, sorry, who was asking that question? That was, if I understand,
Me, Faisal.
puzzle. Exactly. There is some problem in this. Okay, just I'm asking for 1 minute. I'm just deviating. Are you facing any problem while attending the lectures with Microsoft Teams?
Sir, it's just your voice is breaking a little.
No, 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 no. That is an internet issue. That is an internet issue.
No, sir. Teams is
Faisal,
working fine for us.
Pardon?
Teams is working perfectly fine for us.
Okay, I do not know.
So, but several professors are facing issues with Teams this semester for some reason.
Yeah, I do not know, but I'm facing a lot of minor issues. Sometimes it's major, but sometimes it's minor. Even today morning, it took me almost 10 minutes to log in.
Yes, sir. Same thing has happened in other courses. Even other professors are facing issues with Teams suddenly.
Basically, these will be the feedbacks that will give it to the administration. That's why I was asking if you are facing any problems because the problems might arise due to my fault, due to technical fault, due to something else. We cannot exactly find out where it is lying. But once we get the feedback and share it with the CIC people, they might figure out. So That's why he asked. Anyway, so you people are not facing any problem while using Teams.
No, sir, but many professors are.
Okay, thank you, thank you. So now the question is, just think, I'm giving you the real life. This is a very, very childish sort of like what is Robinson Crusoe Friday? That's an example from kindergarten storybook, right? So I'm giving you a kindergarten story to start with. But if you think hard, if you think in the correct direction, you can understand basically our target is how to tax private goods and create public goods. So this distribution is based on a welfare function where you can have, say, from a policymaker's perspective, a bunch of private goods which you can purchase from your income. But there are a number of poor people in the economy. How to compensate them? There are too many ways actually. One, I tax the rich people. Might not be the income, might be the goods they purchase, indirect taxes. That's why we have a set of direct taxes and a set of indirect taxes. And that collection is converted into two things. One, provision of public goods like free healthcare, free school, free education, roads, drinking water, sanitation, or presently speaking in today's world, trying to achieve the sustainable development goals, SDGs. That's one part. Second part, there are direct transfers, benefit transfers, cash transfers, with which they can purchase public, private good. And that is the redistribution I'm actually talking about. That is the target. To achieve that target, we start with a very simple kindergarten story so that you can understand the mechanism. And the mechanism is when the government does this redistribution, it incurs a cost. And the cost in real terms, suppose I have only apples and oranges, will be in terms of apples and oranges. Because there is no money or anything else in this economy. In this kindergarten economy, there are apples and there are oranges. Or even less, there are only oranges because apples are already equitably distributed. Now, how to account for that loss? The moment, what is this loss then? This loss is nothing but there are resources in the economy which are scarce. There is no resource in any economy which is unlimited. Neither capital, nor labor, nor natural resources. Nothing is what we call abundant because there is a demand for everything. What is a demand? There is now why public goods are important? Because for public goods, the willingness to pay is very hard to capture because everyone will try to free ride. But the beauty of a public good is everyone can use. There is no rivalry there. So it's better you take away private goods, convert them to public goods, and give it. But in the process, the costs incurred are in terms of real resources, which are getting lost. Had there been no redistribution in the economy, there would have been 12 oranges for consumption between the two people making up the society, Robinson and Friday. But the moment you go for that redistribution to achieve equity, one or some positive amount of orange is lost. So at the end, the consumption bundle for both at max can have 11 oranges. So one orange is lost, which means efficiency has been compromised. So that's the point I'm making. Now, the debates are quite. Okay, by the way, sorry, I missed. Someone had asked that question about the single commodity and two commodities. So I think I have answered that question. Is it clear to you? Or you still have doubt? If you still have doubt, please intervene.
No, sir, it's clear.
Thank you.
So
Yes.
I got confused. Like when we say that one orange is being lost, when the government tries to redistribute, then you said that we'll change it into the good will be changed into private to public, and this will incur some cost. So can you give like a physical intuition to this, like
Running the
the way?
government. That's what I'm telling you. Suppose government wants to take semester fees from you who can afford and subsidize certain students who are meritorious but does not have that much affordability. So that's one type of redistribution, right? A physical example.
Yes, sir.
In the process, the institute must keep one person to do this job because you are not going to transfer to an unknown person. If you had voluntarily given suppose the semester fees, if everyone is able to pay, suppose I'm giving a very hypothetical example, is required is say 50,000 per semester. But suppose 50% of the students has to be subsidized because of their lack of initial endowment, which is their parents' income or their family wealth. Now the question is, will you subsidize at least one? Because suppose I am assuming this hypothetical situation of a distribution, probability distribution, where 50% can afford, 50% cannot. So I'm again taking a very hypothetical scenario of 1 and 0, binary. One who can pay the fees, one who cannot pay the fees. So I'm not saying I can pay partial fees. I'm not bringing in those complications. Now, if you had transferred, so now look, basically to run the show, you need all the students paying 50,000 per semester. But you know, only 50% can afford. So if each of those who can afford sponsor one who cannot afford, then there should not exist a government. The government exists because no one is going to sponsor the other. So now what the government does, instead of 50,000, take 1 lakh from you and give free to another person, which is accounting for 50,000 for both. But to run this show, to run this redistribution, you need one person at least, and you have to pay salary to him. So his salary will be deducted from this available resources. What is the available resource? The available resource is 50% of students willing to pay 50,000 rupees. But now you're enforcing 50% students paying 1 lakh and sponsoring the other 50% of the students. But at the same time, you have to maintain an administrative staff, which incurs a cost. So the actual economy, which was paying semester fees and getting education, from that, one person who is neither educating you nor paying semester fees, but getting a salary for this redistribution process. To run a government, you incur cost, which can be translated that the government's idea of providing public goods or providing an initial redistribution mechanism, providing a tax structure, all these things require cost. Had there been no government, you would not have incurred this cost. Let's go back to a basic macroeconomics national income accounting identity, if you remember. Y is equal to C plus I plus G plus NX. Had there been no government, there will be no G. What is G? Predominantly, the plus sign is the government expenditure, the negative sign, the government revenue. Now, from the government's perspective, the plus sign is its revenue, negative sign is the expenditure. Now, if the expenditure is more than the revenue, we say it's a deficit. But the problem is, one is forgetting a basic idea that within this expenditure lies a particular component, which is the cost of running the government. And this is exactly what the government is trying hard to do for a very long time. And we call it austerity measures, trying to cut the overhead costs. Because I am earning something, I am giving something. The absolute efficient system will be what? I take something from the rich and I give exactly the same amount to the poor. But that cannot happen. That's not feasible, because you need a government mechanism to run and there is a cost. So real resources are absorbed in maintaining a particular institution which is doing the redistribution. So real resources which are not going into the final consumption but lost. That is the source of inefficiency. So now if you look the debate, you will understand. The nature of the trade-off itself. I need to reduce inequality. I take certain measures. I know some efficiency will be lost. How much I can afford? So will that one orange vanish, or less than one orange will vanish? The second thing is, I have reduced inequality by a certain level, and also in doing that, certain level of inefficiency has increased. So how much relative value as a planner, as a government, one should assign to these two increments? Because if you start from the reverse thing, that this sorry, this initial situation is redistribution happening, and one or half the orange is vanishing as cost of redistribution. Now you want to stop that redistribution to achieve inefficiency, to achieve efficiency. So it's a reverse way. So okay, let's not poke our nose into the redistribution. Let the market determine what it does. Adam Smith, laissez-faire, no government, not no requirement of government. Then how much efficiency will increase? So I have on one hand, if I move from point A to B, there is a decrease in inequality. If I move from B to A, there's a decrease in inefficiency. How much relative value I'm giving to these two? There are two groups, as I said. Group 1 postulates. Group 1 means someone like, take for example, what we call the more development oriented economists. They will say inequality is the central problem. Why inequality is a central problem? That does have a strong economic logic. If you have very high inequality in a society, I'm talking only about income inequality. For the example, take for example Indian agriculture. Why are we seeing so much agitation? Is it only about a farm law? No, it is deeper. Data from MOSPI. MOSPI is Ministry of Statistics, Government of India. Tells you 60% of Indians are employed in the agricultural sector. And the agricultural sector contributes to 16% of the GDP. Which means, if you remember national income accounting, you can actually say that means 60% of population is having 16% income. Which means the rest 40% is having 84% income. Which means 84% or even more number of people in India can hardly save anything. Whatever the income they have, they spend in immediate consumption. So if 80% of the 80, 84, 85% of the population cannot save, which means there is no investment in the economy coming from this chunk of population. So potential of investment lost. If you stop the inequality, if you give more money to these people, marginal propensity to save will increase with income. So there will be in an aggregate much higher savings in the economy, which means there will be much higher investment in the economy. And from C plus I plus D plus Nx, if I increases, Y will increase. So tackling a problem of inequality will lead to higher MPS, will lead to higher investment, will lead to higher GDP, will lead to higher GDP growth rates. So that's the first view. So you start with development, growth will be achieved. The second group, who are more the growth economists, they have exactly the opposite view. They'll say efficiency is sacrosanct. Because to achieve equity in the economy, equality among people, equitable income distribution, what you're doing, you are sacrificing efficiency, which is offense. Efficiency is sacrosanct. Why? They also have a strong logic. And the logic is, if the economy is efficient, growth will take place. Direct impact. If growth takes place, means Y goes up. So you just increase the shares. It is not about a apple pie which is constant in size, and one is getting a larger share, one is getting a smaller share, and you want to take one, you are taking, suppose it's like a pizza, you have having 6 pieces of that apple pie, one is having 2, another is having 4. It's not like that you have taking one slice away from the first person and give it to the second, so that everyone has 3 slices. Increase the share of the size of the pie. Go from a medium sized pizza to a large sized pizza. If you do not sacrifice efficiency, today's medium sized pizza will become a large sized pizza tomorrow. Everyone's share will increase. So efficiency is sacrosanct. Now look, as I said, this actually we'll finally delve into what we have somewhat said, like the voting mechanism. Suppose you have, as you can see in US, it is very common. You have a Democrats, you have the liberals, right? And suppose one says inequality is problem, the other says efficiency is problem. People vote based on that agenda. The winner is nothing but the person who has got more votes, which means we are into the domain of majority voting. And that is the beginning of what we call political economy. So this public finance, public economics, policy design, and political economy all are intrinsically related. And just to assure all of you, when we talked about first welfare theorem, second welfare theorem graphically, it looks a little vague. But when we do a problem, we understand it's actually not vague. There is a mathematical basis to these things. And if you can understand, when we will, maybe in the next module, club majority voting, we're using basically a mathematical tool, the median voter theorem. So there is a mathematical theory behind all these things. So do not think when I'm talking about political economy, I'm talking about politics. Politics and political economy are separate things. Now, so to understand this nature of debate and the values or the relative strengths, we go back to the very basics. That is utility maximization of individual. Remember, we talked about utilities possibilities curve. Do you remember how we got it? Okay, let me stop sharing.
So the budget constraint line and the indifference curve touch at a
That
point.
is that is utility maximization, but I'm saying utilities possibilities curve, which I
Oh,
did, yeah, which I did few days back. So I'm just trying to just hold on for a second. It's very difficult to draw a straight line using a mouse.
so it was of all the points where if we take two people, then their like both of them have equal MRS. So
Correct.
like it
So we
was
had this Pareto set. You can
yes,
see
yes,
the. I think everyone can see this. What I can say, the whiteboard. So
yes,
these were the emerging things, and from there, what we drew was something like this. Because here you have utility of individual 2, and here you have utility of individual 1. The trade-off. The moment you move from the southwest origin towards the northeast origin, means individual one's utility is continuously increasing along with the decrease in the utility of individual 2. Someone asked, if I remember, why it is convex. It is concave to the origin, right? Why it is concave to the origin? I said because of diminishing marginality for both the individuals. Now we can verify that. Now the question is, so I hope this recap of utilities possibilities frontier is done for everyone. I think everyone could see the whiteboard.
Yes, sir.
Okay. So now what we do is we can come back to the slides. So if the economy is efficient, which means it is, I am taking all the points on a Pareto set. In turn means the economy is operating on the utilities possibilities frontier. So the first welfare theorem that tells you automatically that if markets are competitive, the efficiency is not lost, and we are always on the utilities possibilities theorem, utilities possibilities frontier. And the second welfare theorem, what does it tell? It tells that with initial redistribution, any point on that utilities possibilities frontier can be achieved, right? So I'm just redefining the first and second welfare theorem on the basis of utilities possibilities frontier, away from the Edgeworth box. So I am just discarding the Edgeworth box for the time being, coming to this very simple utilities possibilities frontier. First welfare theorem says competition leads to operation of the economy on the frontier. Second welfare theorem says with some redistribution in the initial wealth, initial endowment, you can choose any point on that which is called possible disadvantage. Right? No confusion. So now if you understand the answer to the first question, which Pareto optimal point to or Pareto optimal allocation to choose, that will boil down to which point on the utilities possibilities curve to be chosen. So for when we talk about individual utility maximization, as you correctly pointed out, it is nothing but I have a set of indifference curves given by my preference function. I have a budget. So the tangency, so pictorially, graphically, the tangency between the budget line and a particular indifference curve will give the optimal consumption. Now for every indifference curve, what is the trade-off between the two goods that you consume? However, if I want to have a social indifference curve, it needs to take care of the trade-off between utility levels of different individuals. So that is the difference. Individual indifference curve comes from your utility maximization. Your utility is defined by consumption of good one and consumption of good. So the indifference curves gives you a trade-off between the consumption of these two goods for a particular individual. Now, when we talk about utilities possibilities frontier, at any particular point on that utilities possibilities frontier, and I think of a social indifference curve, then basically I have to consider trade-off not between two goods, but the trade-off between the utility levels of the different individuals. In this case, the two individuals. Remember the utilities possibilities frontier, that space. Vertical axis, I have one utility. Horizontal axis, I have utility of the other person. So it's a utility space, not a quantity space. So this is the trick of the social welfare function. So a social indifference curve gives you the combinations of utilities between which the society is indifferent. So I'm defining it for the time. The moment you have a social indifference curve, you know that it describes or it captures the trade-off between utility levels of the two individuals. So if the utility level of one individual goes up, the other should go down. But all these points, so different combinations, the locus of all the combinations of different utilities of the two people, such that the society is indifferent. Second thing, on a higher social indifference curve, the society is better off. So the social optimal will be something like this. So suppose you start with a particular endowment point, leave it to the market, competitive markets. You reach a particular point on the Pareto set, which is depicted by point A in the utilities possibilities frontier. Here you can see Crusoe has very less of good 2 as compared to Friday. Now this is any point on the utilities possibilities frontier is Pareto optimal. So movement from A to any direction will lead to change in the utility levels of the two people involved. If you go from A to downward direction, what is happening? Utility of Crusoe is increasing more and that of Friday decreasing. If you go from A upward on the left side along the utilities possibility frontier, the utility of Friday increases a little bit and that of Crusoe falls. Now if I have well defined social indifference function from where I can generate the social indifference curve, and like indifference map, I have the social indifference map. I can see that point A lies on a social indifference curve S0. Without compromising efficiency, I can move to B such that I can achieve S1. If I can achieve S1, it corresponds to point B, which means if I can somehow, through the second welfare theorem, redistribute the initial wealth by taking some from Crusoe, giving it to Friday, and leave it to the market, then instead of A, B will be achieved. But with the achievement of B, social welfare goes up. So B will be the optimal point. So you can actually draw another indifference SIC here. Sorry. Which means, suppose you move to this point. Suppose this point is C, where the cursor is right. That is also a Pareto optimal point. But Friday's utility is more, Crusoe's is little less. So I am moving in the direction of a more equitable distribution. Why? I am moving from S0 to this red SIC, which is higher than S0. But what will be the maximum social welfare? B. Only there I can achieve the maxima of the social welfare. Now, the question is, it's so easy, it's so simple to look in this two-dimensional space. So had there been this kindergarten economy between Crusoe and Friday, so only two people, it's very easy. Why can't we implement the same in real life? Here I will make two caveats. Defining the social welfare function. You have a preference function or utility function, right? From there you can have the indifference curve. Similarly, the SIC is contingent upon the shape, the properties of the SIC is contingent upon the welfare function you define. And the welfare function should consider the utilities of innumerable individuals. So the type of weightages you should have to give, you need to give to different parameters of that function gives the shape of it. The problem with SIC, which I will show you later, is unlike individual indifference curves, SICs can intersect. Now, if social indifference curves intersect each other like the one I have done right now, A and B become incomparable. Why this is lost? Because of certain axioms of basic microeconomics. In while defining individual preference and hence drawing non-intersecting ICs, we have made one assumption, or we have stuck to one axiom. Can anyone tell me what was that? Why do individual indifference curves do not intersect? What is the assumption?
Sir, on an indifference curve, the utility is constant, and if there is another utility curve, means it is another constant, and if they are intersecting, then it means that both of them have the same utility.
Exactly. Look, suppose forget about social indifference curve. Suppose the graph that you are seeing on the front in the screen right now, on the screen right now. Suppose this is consumption of good 1, suppose this is consumption of good 2, and the indifference curves looks like this. S0, S1, and this red one. Point A and point B you cannot compare, right? What is getting violated? On the other hand, we always know that for given a particular assumption, this red type of individual indifference curve can never happen. It is only S0 and S1. They are non-intersecting.
Indifference curve cannot intersect.
Yes, why? That's the question. Why? What is the assumption we made?
So then there will be two values. Like
No, I'm not talking about the implication. I'm asking why. There is a critical assumption in microeconomics we make about individual preferences. And the result of that, indifference curves cannot intersect. So what was that assumption? What are the axioms of preferences? Try to relate. This is where we have to think.
Sir, a higher curve will give higher utility. So,
Cool, no problem. So you are
so sir,
talking
any
about the
point above S1?
you are talking, all of you are either talking about implication or talking about the characteristics. I'm asking that there is a particular characteristic of indifference curves when we talk about individuals.
Monotonicity.
No, not necessarily.
So diminishing rate or substitution.
That is okay. That is already taken care of.
So like basically the individual is indifferent in that basket
Is
of
it
goods.
the fundamental axiom of transitivity?
Exactly. Who is that?
Adrija.
Very good, Adrija. Exactly. There are three basic axioms of preferences: completeness, reflexivity, and transitivity. If I prefer bundle A over B and prefer bundle B over C, then I definitely prefer bundle A over C. There is no circularity. That is why individual indifference curves never intersect. Look, from here, just think on the screen, you have one individual and consumption of two goods. Horizontal axis, instead of utility of crucial fruit, C1. Vertical axis, C2. And you have S0, S1 and this red one. If I am at S0, I have A. If I am at S1, I have B. S0, S1 do not intersect. I can seriously say A lies on S0, B lies on S1. S1 is a higher indifference curve and hence A is preferred to B. Sorry, B is strictly preferred to A. Now suppose there is an intersecting IC passing through both A and B. Then if that one indifference curve intersects like this, then I'm indifferent between B and A. So from S1 and S0, I'm saying B is strictly preferred to A. From the red one, I'm saying B and A are indifferent. Transitivity is lost. And that is why individual indifference curves do not intersect. Now the question is, why then social indifference curve might intersect? Now think and give an answer. Adrija, you will not answer. Apart from Adrija, I am expecting an answer from at least one of you. The question is, now it is clear to me why individual indifference curves do not intersect. Then why should social indifference curve might intersect?
Sir, because social indifference curve may take into account the total of the
Exactly.
population.
Obviously, by definition, it is. Then why? Why it might intersect?
Sir, it doesn't care if the utility of if the utility of one is compromised and the other is increased, if the total is increased,
No, no,
the total
no,
remains the
no,
same.
no. That's a definition you are giving.
So we can't draw such simple preference hierarchies in society, like
Correct. Who is that?
Abhinav.
Yes, Avinav.
So
It is
like for
possible
example,
that
let's say
I prefer A over B and you prefer B over A. So when we aggregate it up, the society might be indifferent between B and A. I love apples over oranges. You love oranges over apples. Simple. Different people, different preferences. When we club it together, it might well be that these two bundles, suppose there are two bundles B and A, where B is strictly preferred by me and A is strictly preferred by you, then B and A, only two of us, society will be indifferent between B and A. That is the reason why social indifference curves intersect. We can assume something more addition to individual preferences to rule out this intersection, but that we'll do later, not now. But for the time being, I think all of you might understand there is a problem with social indifference curves. They might well intersect. Take for example, I give you a more realistic example. Instead of Crusoe and Friday, create two groups, rich and poor. And in the original Edgeworth box, make the two goods public and private. Rich will prefer more private goods because they can afford. Poor will prefer more public goods because they can't afford. So if there is a bundle of public goods and private goods, a bundle having more private goods and less public goods will be preferred by the rich, and a bundle with more public goods and less private goods will be preferred by the poor. A rich person does not really care about a particular street light in front of his house. If the street light is not functioning, he can purchase a light and put it there. He doesn't mind. But for a poor person, a street light is very important. For a rich person, the public distribution system, PDS system, the ration shops, we never visit. We always go to the market, Spencer or somewhere nearby available place. We go and purchase it. For the poor people, the ration shop is very important. And that is why for the government, it's a very, very difficult job to balance between efficiency and equity. Because it is very difficult to create a social welfare function which takes care of everything, including that the resulting social indifference curves will not intersect, so that the government can optimize the social welfare. And that is the trick. And that is the problem. That's the core, the crux of the problem. Okay, this I have already talked about. This I have talked about. Now let's come to the trade-off, transfer problem. Now, when we looked into that, let's forget about the intersection for the time being. When we talked about those two non-intersecting social indifference curve S0 and S1, point B on the higher social indifference curve, and both A and B on the utilities possibilities frontier. So efficiency is not lost. So movement from A to B, what is happening? Friday's utility is increasing, Crusoe's is falling. Now, look from A to B, what is the utility lost for Crusoe? This horizontal part, the point from where the cursor is to point A, this much. Utility gain by Friday, this much. So the gain in Friday's utility is more than the loss of utility of Crusoe. That is why the social welfare is going up. Because Friday's gain is more than Crusoe's loss. So somehow, if we can quantify this in numbers, what I can see, look at the vertical intercepts, U1F minus U0F. That is larger than the horizontal intercept U1C and U0C. So U1F minus U0F is greater than U0C minus U1C. So if the government does something that the economy moves from A to B, social welfare is maximized, but Crusoe's utility is coming down. Still, I can see that Friday's utility has gone up by more than the loss of Crusoe's utility. So let's consider this particular picture. Movement from A to B to C. Okay. So suppose the economy starts with A, with some initial transfers goes to B, and again some initial transfers goes to C. What is happening? From A to B, loss of Crusoe's utilities UAC minus UBC. Gain for Friday, UFB minus UFA. Quite large. B to C. By construct, what we have done, now the difference is UCB minus UCC, which is exactly equal to UCA minus UCB. So these two horizontal reductions, or these two reductions in Crusoe's utility are same. But from A to B, Friday's utility is going up by this much. Same reduction again, going by this much. Now UFC minus UFB is still greater than loss of Crusoe's utility of UCB minus UCC. No problem. But this increment is less than the first increment. This is the reason why you I might understand the diminishing marginal utility is creeping in. More of something is always better. But is that true? Is that true for every level of utility? So I'm asking all of you a very fundamental question of preferences. What we know, if there are individual indifference curves, if I move up to the higher indifference curve, my utility goes up. So if I have more of both the goods, of at least one of the goods, keeping the other constant, my utility will go up. Can that go up infinitely? Will anyone try to answer that question? Just think. We know there was a particular assumption we learned that more is better. Fine. Forget about social indifference curve, utilities possibilities frontier. What you have, suppose think these red graphs as indifference maps, right? Indifference map looks like this for an individual. And suppose keeping I'm moving in this direction. Both goods are equally increased in your consumption basket. But is this movement possible till infinity?
No, no, sir.
Why?
Sir, because like there are resource constraints, like we can't have infinite number of anything.
Suppose
Like
I can provide a particular person with increments in both continuously.
So there is budget
he can't
Pardon? There's someone else was saying something. Divyansh, I'm just coming back to you. Yes, who was that?
budget.
Hello?
Hello.
Yes.
So there is budget constraint.
Suppose I'm relaxing the budget constraint. I'm providing you. That's exactly what Divyansh was saying.
So I think there is the propensity to. I mean, if you take a real life example, in the more developed countries, right? The even if they are wealthy, at some time they like to do the charity work and all, right? So after some time, I don't think the the utility increases that much, even if you consume more.
You have just used a particular word which I like, charity. Yes, rich people like doing charity. Absolutely. True. Why? They could have they kept on consuming higher and higher, right?
Yeah, yeah, but they
Why
don't,
not?
right?
It's a kind of
Why not?
investment.
Saturation, sir. They're saturated.
You're quite close, Abhinav.
Because of tax.
Because they no, no, look. we use a particular term in economics, not saturation, but we call it satiation. Remember, non-satiation, axiom of non-satiation.
Non-satiation is more is always good.
Right? So
So
is it always true? You need to remember one more concept to answer this question. Okay, let me give you the answer. What is bliss point?
Only that particular combination of goods can be utilized.
Bliss point.
Yes, sir.
Sir, the consumer wants to converge to that particular combination when he finds it suitable.
Why we call it a bliss point?
Sir,
Remember the arrow that
because
I have drawn on the
consumer
slides?
derives highest utility.
Exactly. So what is something that we are not drawing here?
Sir,
Why I am saying
diminishing.
no diminishing is here? Diminishing marginal utility is here. What I'm saying, suppose shape a small circle like this. This orange dot is bliss point, and then by definition my utility can go up only till this point. Then what I'm missing?
The bliss point is about maximum satisfaction. So
Exactly. So that is exactly what we're seeing. Suppose this is the minimum utility level you can achieve. Bliss point is the maximum utility level you can achieve. But it's a point. So what am I not showing in this particular graph? Consider only the red lines. Forget about the actual graph.
So there will be like circles around that point.
Exactly. Exactly. Who is this?
So Priyansha.
Okay, Priyanksha. That means we
So,
have
but I
drawn.
have a question.
Yes.
So,
We
is
have
it necessary that we always there always exists a bliss point?
basically that I will answer. That's a nice question.
sir,
Basically, what
isn't
my yes,
sir isn't bliss point violating non-satiation? More is always better, and then
no,
there's a bliss,
no,
maximum bliss.
no, no. It is not, because indifference curves are not only this part which are showing you. It's like a circle. Now you continuously go up. You put it here. Draw a smaller circle, right? This circle will be smaller. So these are basically concentric circles or ellipses. They are not circles, they're ellipses. Why? Now I'm answering both these questions together. Is it ever reached? Is it violating non-saturation? It is not. Because there, to reach bliss point, the amount of resources that one has to accumulate is infinite. Secondly, it is not violating non-saturation because of the nature of the preference curves that we actually see. But what we work with is only something like this, because I know the portion above it. So this is nothing but the interior most point of the better set, right? Will never be achieved. So it's a theoretical possibility. Practically, it will never be achieved. If I just define our utility function in terms of consumption of good 1 and consumption of good 2, then for all practical reasons, this will never be achieved. Theoretically, it is possible. Because theoretically, the preference curves are ellipses, not these things. So these are nothing but subsets of indifference curves. We are just drawing a partial picture of the indifference curves. Now, there are indifference curves which look like this. Quasi-linear indifference curves. Straight lines. When do we have them? When we have two substitutes. Right? For complements, we have L-shaped. For substitutes, we have this quasi-linear or say linear indifference curves. So in those special cases, this will not happen. But in the generic cases, basically there is a theoretical possibility of reaching a bliss point. So I will request, let me write down. Where is this? Yeah. So for all of you, I'm writing down something. Read the chapter on consumer behavior from a book authored by can you see this text that I have dropped in the chat box?
Yes, sir.
There is a microeconomics book by Gravel and Rees. Just for brushing up these finer concepts, read the chapter on consumer behavior from this book. I am not asking for Maskell, Winston, and Green, which is even more stronger. MWG, no, not required for the time. But yes, Gravel Rees is a very, very standard textbook. Just hold on for a second. Uh, so can you see this textbook? This microeconomics by Gravel and Rees. Sorry, I misspelled. LLE. It's a very common, very simple book. Just read the chapter on uh, So there are 3 chapters basically. Chapter 3, 4, 5. What I will say, just read chapter 3. So basic concepts of these preferences, they will become more and more clear. So now, is the slide visible again? I have reshared the slide. What happened?
Yes, sir, it's visible.
Okay, thank you. Thank you. So this is a homework for all of you. Over the weekend, just have a look. This will actually help. Because most of the time what happens when we read microeconomics or macroeconomics, we are at the beginning of our study. And we start with the simplest thing. Then we keep on studying more complex papers based on either micro or macro, right? So if you talk about finance, portfolio balancing, that is also one type of optimization. That's also micro behavior. When you talk about hard behavior of investor sentiments and everything, that's a macro behavior. There are only 2 core prisms of economics, micro and macro. But when we read these things, we are in the first semester, second semester, like that. So we start with a very, very simple thing. But in doing so, we sacrifice on certain finer issues. And that is why one should always have an advanced micro course, always have an advanced macro course. So in fact, if someone of you goes to a decent university in US to do a PhD in economics, there will be a MS coursework, it will be an MS PhD, the 2 semesters. You'll always have 4 subjects only in the coursework. MS micro 1, micro 2, macro 1, macro 2, stats 1, stats 2, or stats and econometrics, math eco 1, math eco 2. That's it. Your specialization you can take up after reading these things. Any specialization you can take up. So micro is very, very important. So is macro. Everything else are nothing but applications of the finer concepts. Even if you look into international economics, you're studying right now.
No, sir, we have read the
No, sir,
record.
it will be offered in the coming semester.
You will find there are 2 parts only. One is a micro analysis, one is a macro analysis. The micro analysis will be in international trade. The macro analysis, open economy, macroeconomy will be in the international finance part. Similarly, public finance and policy. We are now in the domain of micro. Later, when it comes to that positive analysis, where I have to take care of everything, financing this, financing that, I have to go into the domain of macro. So there are only 2 prisms. So I'll just request all of you, for the time being, just read chapter 3 from here. You'll understand. It's really, really interesting. You have not, either you have not learned or you have missed the finer issues. But these are very, very important. Okay. So now, as you could see, this increment, look, the loss for Crusoe are equidistant. But the first increment is larger than the second increment for Friday. So when I move from A to B, Friday is better off. B2C, Friday is even better off. But this marginal increment is becoming lesser and lesser when I move in this direction. From A to B to C, if we go to D, it will further come down. So social optimal will be there where your SIC is tangent to your utility possibilities frontier, UPF. But in this movement, this marginal utility is falling. So this increment, second increment for Friday's utility is lower because of diminishing marginal utility. So the moment you take oranges from Crusoe, his utility decreases. So the utility he loses for each additional loss of an orange. That is important. So when Friday's income is very low, in this example, when Friday has very few oranges, just giving a minor number of oranges from Crusoe to Friday's initial utility will jump up by a lot. But if you keep on doing it, then Friday's incremental utilities will keep on falling. So if you have a very large number of poor, or at least one person who is very poor, a very small transfer is going to increase social utility by a lot. And that's the trick. And that's the takeaway. You have to take very small amount from the rich and give it to the poor. So the utility loss of the rich will be marginal, very, very small. But the utility increase of the poor will be very high. And so social utility goes up like anything. But is it again a continuous process? No. The social utility will keep on increasing till this distance. Suppose you are giving these distances are 1 oranges. UAC to UBC. This one is 1 orange transfer. But UBC to UCC, second orange transfer. So this will go on till this horizontal intercept for 1 orange is less than or at the margin equal to the increment of that of Friday's utility. Now, if you look at a point like this, what will happen? Friday's incremental utility will be less than loss of utility by Crusoe, which means the society has flipped. Now Friday is a rich man, Crusoe is a poor man. So somewhere here in and around C, you expect the social welfare to be maximized. Okay, so sorry, I think I did not take a break or anything, but we had a long discussion, so I'll stop sharing. So let's end the lecture today here, and we'll start again from this social welfare and utility transfers, all these things from our next lecture. So if you have any questions, please go ahead. And who told me to discuss a couple of questions from yesterday's
So me, sir, Shachi.
Shachi, right? Uh,
Yes, sir.
Shachi, I have a different plan.
Yes, sir.
What I do basically, because this is the first exam you are giving with me, so you do not know. But those who have done lectures with me before know that most probably before the next lecture or in the next lecture, I will circulate the answer of the questions. But if you still have some minor questions, you please go ahead. No issues. But I do circulate the answer key after examination.
So for the numerical questions, apart from the answer, will we get the solution also, like how we reached till the answer?
No, this is
So because like one of the questions I have that doubt ki, like I didn't get how we'll reach to the answer itself.
to answer your question. I have to stop recording and let me stop recording. I'll answer your question.